Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2023. Question number 4 is on magnetism and electromagnetism. A teacher demonstrated the motor effect. Figure 5 shows the equipment used. The equipment includes a permanent magnet. So you've got a permanent magnet here with the North Pole and South Pole. So the magnetic field is actually going down in this direction. The copper rod remains stationary while the switch is open. Complete the sentence. The tendency for an object to remain stationary is called inertia. When the switch is closed, the copper rod accelerates, which means there's a resultant force on it, so it actually moves. In which direction will the copper rod accelerate? So they have given the 4 directions, either down, to the right, up, or to the left. So let's use this diagram. So you'll have to use Fleming's left hand rule here. So Fleming's rule states that if I draw the diagram, right, force, the magnetic field, and the current, that's your thumb, first finger, and your second finger. Now the field is pointing downwards and the current goes from the positive towards the negative. So the current is in this direction coming down, it's going here, and on the rod what matters is the direction of the current which is coming in the rod. So it's actually coming out towards us, out of the paper. So the force, the field is actually pointing down. So if I was to draw the same diagram, right, this is my thumb, the field, and that's the current direction. So you can see that there's a force pushing the rod outwards. So the answer is number 2. 4.3. Explain one way the teacher could increase the acceleration of the copper rod. In order to increase the acceleration, you can do 2 things. Either you could increase the current, or you could change the magnet to a stronger magnet. The easiest is actually to change the current, because you have a variable resistor here. So you can actually change the resistance here to increase the current. So because they're asking you to explain, you'll have to say what actually it does. So increase the current, so the resultant force increases. 1 mark for each of those points. Next question, figure 4.4. The magnet used in the demonstration was a permanent magnet. Figure 6 shows an iron bar and a permanent magnet. Describe how the permanent magnet could be used to test if the iron bar is also a permanent magnet. Now, if the iron bar is a permanent magnet, if you bring the south pole to this end, let's say X, if you bring the south pole to this end, if it attracts, and then if it also attracts the north pole of the permanent magnet, then it's definitely an iron bar, because it doesn't have any poles. Now, if it did have a pole, right, then when you bring the permanent magnet, one end of the permanent magnet, to either side of the iron bar, then it would repel and attract. It would attract one side and it would repel the other. So how do we write the answer for this? Bring the same end of the iron bar close to each pole of the permanent magnet. Any repulsion shows the iron bar is a permanent magnet. Or you could say, if one end of the iron bar is attracted to both ends, both poles, it is not a permanent magnet. Question 4.5. Figure 7 shows a magnetic compass used by walkers. Explain how a magnetic compass provides evidence that the Earth has a magnetic field. Now, the Earth has a magnetic field, and the compass, which is held here, is actually aligning to the Earth's magnetic field. Now, if you walk along far enough, you will see that the direction of the needle also changes. That's how we know that the Earth has a magnetic field. So the compass needle always points in the same direction because it aligns itself with the Earth's magnetic field. Doesn't matter which direction you change, it will always point in the same direction because it's pointing in the Earth's magnetic field. That brings us to the end of question number 4, and I will see you in question number 5.